Oxygen moves down a partial pressure gradient from the atmosphere into the alveolus, then into the arterial system. P big A is the partial pressure in the alveolus, P little a is the partial pressure in the artery. Now this one always has to be bigger than this one because oxygen has to move down a partial pressure gradient. This is what we mean by the AA gradient. It's simply the difference between the alveolar partial pressure and the arterial partial pressure. If oxygen is not getting across this barrier, across the alveolar membrane effectively, then you're going to have a much higher amount in the alveolus than you are going to have in the arterial system. So a raised AA gradient can tell you that there is ineffective gas exchange. So by calculating the AA gradient, we get useful information as to why our patient is hypoxemic. Now this number you can just measure on an arterial blood gas, but this one you can't measure, you have to calculate it. And you calculate it using the alveolar gas equation, which we've talked about elsewhere, but as a quick recap, the alveolar partial pressure is how much oxygen you're breathing in, so it's atmospheric pressure minus the humidification pressure times by the FiO2, the percentage inspired oxygen, and then you take away however much oxygen is being swapped for CO2. And those terms are all measurable or estimatable, and then you can plug all those numbers in. It will give you an alveolar partial pressure of oxygen estimate, which then you can take the arterial value away from and get your AA gradient. So causes of an AA gradient are anything causing VQ mismatch, anything that means oxygen is not getting into the alveolus and then into the blood. Subset of this is right to left shunt, which falls under the categories of VQ mismatch as well. And lastly, if there's substantially increased oxygen extraction from the blood, then there's just less oxygen in the blood as a baseline. Normal AA gradient in a non-smoker, relatively healthy young person is less than 2 kilopascals. In an elderly patient, it is less than 4. So to give you an example, if you have airway obstruction or something higher up than the alveolus, causing a lack of oxygen entering the alveolus, then both the P big AO2 and the P little AO2, they're going to drop. And if there's no problem here, then they're going to drop at basically the same amount, and you're going to have a maintained normal AA gradient. Both these numbers will be low. However, if you have pneumonia and you've got consolidation thickening your alveolar membrane and making gas exchange much less efficient, then oxygen is getting into the alveolus quite happily, or at least into these airways, but it can't get across into the blood. So this will be much higher than this, and you'll have a raised AA gradient, and it will tell you that you've got a VQ mismatch. You may be ventilating but not perfusing, or you're not ventilating effectively an alveolus that you are sending blood to. Raised AA gradient simply gives you information as to why your arterial oxygen levels are low.